This is USACO 2017 January Contest Silver. Problem 1, Cow Dance Show. Basically, we have N cows that needs to dance in the order 1 to K. And there can be K cows dancing at once. And we need to find the minimum value of K cows that dance at the same time within the time frame of T. This means that when N is 5, that there's 5 cows that wants to dance, and 8 is the time limit, and 4 is the answer, which means 4 is the smallest value of the number of cows dancing at once, while the total dance limit being 8. This means if this is the stage, there can be 4 cows on this at once. First number 1 comes in, number 2, 3, 4. 4. Number 1 finishes dancing, so another cow comes in, and the total time spent here would be 8, because 4 plus 4 or 8. And this won't work if it was a smaller stage, say 2, because number 4 comes in, 7 comes in, 4 finishes dancing, number 8 comes in. It already exceeds the time limit of 8 by being 12. 4 plus 8 is 12. And one might think at first that this takes linear time to complete, because we need to check for every single value of K that works. But this can be actually solved with binary search. And this is significant because in linear time, we can solve the problem in n squared time complexity. But this just won't fit the time, since the data is 10,000. 10 to the power of 5 to the power of 2 is 10, which is way too long. So instead, we'll use binary search, which cuts the time to O log n times n. And it'll actually fit into time. We can do this by having a low, which starts off at 1, since the best case scenario, there's only 1 cow dancing at a time, and everything completes in the time limit. And the worst case scenario, all cows dance at the same time. And then while low is less than or equal to K, we can set a middle value, which would be just the minimum or the mean of low and high. And we can create a function that checks whether this value is sufficient to complete the dance in the time limit. We can call this check middle, and if it works, we'll need to set high to middle -1, since we're trying to get the minimum value. So if it works, we're trying for a lower value. High equals middle -1, and we'll have a variable answer to keep track of the answer. Answer equals middle. And else, if it doesn't work, we'll need to check for a higher value. So we'll set low to middle +1. Now let's get to the coding part. So far, far, and this just takes care of the input. So first, we'll need to read the integers n and m, n and t, which will be on the same line. So we'll use a string tokenizer to separate them. Static int n and t, n equals integer dot parse int string dot next token, t equals integer dot parse int next token, next. The input will look something like this. So we'll need to read the 5 or the n lines of text, which refers to the dancing cows, or like how long the dancing cows are going to dance. So we can create an array of dancing times. Times equals new int n, for int I equals 0, I is less than n, I plus plus, times I equals integer dot parse int n dot readline. Now let's just check if the code is all correct. We can do n plus t dot toString times, make sure to dot close, and if we run this code, yeah, 58476864. It reads the data all correctly. Now let's comment this code. And now we can start with the actual programming. First, as I said, I'll create a variable called low, which will be at 1, and high, which will be at n. And while low is less than or equal to high, middle is, int mid for short, is low plus high divided by 2. Then we can create a function that checks on whether this mid value is gonna work, whether it's gonna fit all of the dancers in the limited time that we have. And let's call this x. So one way we can check this is create a priority queue, which is basically a sorted set that you can pull for the lowest value. Priority queue, or in other words, a value which has the highest priority, which is the lowest value. PQ equals new priority Q integer. And first, we want to set the stage for the size of the stage, right? So for int equals 0, while it's less than x, we'll add actually, let's make an index so we can keep track of which ones we need to add, or which value from the array we need to add next. So times index, and then while index is less than or equal or less than n, we'll first get the lowest value from PQ, which is int num lowest is PQ dot poll, then we'll get the current time, which would be at times at index, and then we'll add the value of the time added to the lowest value. And what this will do is it'll go through the times array until it's less than the stage size, and then after that it'll remove the lowest value from the stage and then add the next value in the times array. So for example, our data was this, right? And what this code will do is first put in 4, 7, 8, and let's say the value of x will be 4. Then 6. Then it'll get the lowest value and add 4. 4 plus the lowest value, so 8. And then we'll need to get the maximum value from this array to get the maximum time spent with the stage size of x. So while pq.size is equal to not equal to 0, pq.poll, which is removing the smallest value, so we'll be left with the greatest value, and then we'll do return pq.poll is less than or equal to t. And then we can just run the middle value through the function, and this will return true if middle value works. And what this means is that we can create an answer variable and set the answer to middle. And if this works, we want to check for a lower value since we want the smallest possible value. We can set the high to middle -1. And if it's not, we need to check for a higher value. So we'll set the low to middle +1. And lastly, we can print out the answer. Now if we run it, the answer of 4 should be printed out. And now we can submit the problem. The problem on USACO. Oops. Select cow dance show. And the result is all correct. Wow.